to Ashraf, and he can go ahead and get started.
Thank you very much. Hello, everyone. Like you said, I'm Ashraf. I founded Debug Academy 4 or 5 years ago. Today we're going to be going over the command line and Git because I think it's important to be familiar with the command line to get the most out of Git. We'll learn the pros and cons of it. This is taken directly out of our 3-month course. It's about 1 day or half a day of material in our 3-month part-time course. Let's see. So we're going to jump right into it. This just mentions that the training materials provided by Debug Academy. We are local to the DC area. We are open to training individuals and companies. Let me make sure I'm still sharing my screen. All right, there we go. So the screen sharing just resumed. So as I was saying, we're local to the DC area. I encourage you to follow us on Twitter at Debug Academy, where you'll hear about events like this one, free trainings or other trainings in the DC area or entirely online. Let's see. Just finding my way around the webinar controls. The next slide just calls out some of our upcoming courses. Our 3-month part-time course on Drupal 8, accessible to beginners and experienced programmers with different backgrounds, begins in May. And we do have 1-day React.js with Drupal 8 course coming up in DC on March 31st and April 7th. This same React course is being offered at DrupalCon Nashville. It sold out recently, and we opened up the course in the DC area before DrupalCon as well. All right, so on to the main topics. As was mentioned at the beginning, if you have questions, please bring them up in the chat. I will see them in the chat room. So the command line, if you're familiar with it, this part of the presentation won't take too long. If you are not, I'll explain what a command line is by comparing it with a GUI. A GUI is a user interface, which is designed to essentially simplify the usage of applications. If you open up Microsoft Word and you want to make text bold, there's a bold button, a B that you press. There's a U for underline. There's a file dropdown at the top of Microsoft Word where you can press File Save. These are all pieces of the GUI, and they essentially make it a little easier to use an application because you can see in front of you what options there are. The command line is the alternative of that, the alternative to that. I'll pull it up just so you have a quick visual of what the command line looks like. And it's this window here. If you see it on different operating systems or different programs, you might see it with a black background. That sort of thing is configurable. The command line is a place for you to explicitly type commands. CD for change directory. Desktop, I specified the path to the desktop. So in the command line, you explicitly type out what you want to do. You cannot see the options that are in front of you because there are an extremely large number of options. So for example, you don't see a bold button, or you don't see underline or a link to the desktop folder. And the reason you don't see that is because if we showed you everything you could do in the command line, it would just not be usable. That that characteristic is out of necessity. So why would people pick a screen where you have to type commands over something where you can see what the options are? And I'll give the answer with an example. Let's say you wanted to move all of the PDF files from your downloads folder into a folder named PDF on your desktop. Using the GUI, you would maybe right-click your desktop, press Create New Folder, type PDF, click somewhere else, double-click the Downloads folder, find the PDF files in your Downloads folder, and drag and drop into the other PDF folder you created. If there's lots of PDF files, good luck. That might be time-consuming. If you have a lot of files, like I do, a lot of files that are not necessarily maintained, if you're a hoarder, this could take you around 5 minutes. Doing the same thing on the command line, you can run this command, make directory desktop/PDF. So that would create the PDF folder on your computer. And you could then run the move command, move from downloads/anything.pdf. See this notation here. The asterisk stands for anything, anything.pdf. And you want to move it into desktop/PDF. And that's it. The first command created the folder. The second command moves anything that ends in .pdf into a folder named PDF. If you know those commands, if you're comfortable with the command line, doing that could take you around 5 seconds. It's very quick. And this is just one example. So you can't use a GUI as quickly for these things because there's no single GUI command that says move everything that ends in .pdf to desktop/PDF. But on the command line, you can type the exact command you'd like to do and just execute it in 1 or 2 lines. All right, just clear the drawings out. We aren't going to spend too much time on this because the main topic is Git. Command line commands look like this. You start out with a program such as Git. You then say what command you want to do. You can specify arguments for that command, and you can alter the behavior of the command with single or multiple character flags. Descriptions of these pieces of a command are listed here, and every command in the command line is essentially structured using those pieces. So almost every command will start with a program that the command belongs to. So any command we run using Git, we're going to write the word Git first. When using the command line, you'll often have to specify a path. A path as in a location to a file. There are 2 ways to specify a path. You can specify an absolute path or a relative path. And the difference between an absolute and a relative path is essentially the difference between telling someone GPS coordinates, that's the absolute path, or telling someone how to find you from where they currently are. That would be the relative path. For example, if you're going with the GPS coordinates, that one's self-explanatory. If I said the GPS coordinates to where I am, all of you could find me. just like the absolute path, it doesn't matter where you are. The absolute path alone is enough information for you to know where I am. The relative path, on the other hand, is more like saying, turn right, go down 2 miles, turn left, go down another mile, open the door, go up the stairs. That's where you'll find me. Now, that is not enough information for probably any of you to find me. Maybe if there's one person I'm talking to, it might work for you. But in general, the relative path is telling you from where you are, this is how to find what you're looking for. So this is relevant because when you're using Git, you're going to need to specify which files you want to save to history, or which files you want to remove from your code base, and so on. For the most part, excuse that little pop-up in the bottom left. We have some examples of an absolute path in the bottom left. users/Ashraf/desktop/debug academy. That's the absolute path to the debug academy folder on my machine. On Windows machines, you might see the C drive explicitly written out in your absolute paths. For the relative paths, you will see something more like this. You might see things like this used. 2 dots means 1 level up. So if we're in the folder Debug Academy here, and we want to get to the desktop, which is right above Debug Academy, the relative path is just 2 periods, because 2 periods means 1 level up. This is just another shortcut, like 2 periods. If you put 1 period, it means the current directory. Sometimes you need to specify the directory that you are currently in. I'm going through this more quickly than I usually would in our regular semester, especially the next few slides, because this is not the main topic for today. So if you watch the webinar recording and you look back at this, you're welcome to pause it on any of the slides and read for more detail. We have the ls command, which lists files, cd for changing folders, cp, essentially copy and pasting files, mv for moving files, and grep is for searching through files and folders. In the command line, the asterisk means anything. It could be the letter A, B, C, numbers 0 through 9, and it could be more than one of them. So if you just type asterisk, it means anything. So like when I typed asterisk.pdf on the earlier slide, that meant any file that ends in PDF. And there are a handful of examples on this slide. We talked about 1 level up and current directory. And our inspirational blurb for today. I think this is important. Doing makes better. So being a perfect developer is not a thing, but getting better is straightforward. So when we go through the Git material for today, it's important to realize that even if you don't feel like you can use the commands right away, in programming, the formula is relatively simple. The more times you use what you've learned, the better you'll be at it. And because of that, we are going to be giving you a essentially take-home assignment which is a practice assignment for Git, and you're welcome to do that at your own pace after the webinar is over. Okay. Here's that same slide again. I won't repeat it. Now we're going to move on to the main topic, Git. Although to be clear, if you were not familiar with the command line, that is an important aspect of using Git. Now, what is Git? Git is a version control system, VCS for short. It's not the only version control system out there. What it does is it takes snapshots of the state of files in your code base or in your folder at specific times. This is not to call anyone out, that it's a red flag if you do not require version control. It's more of a strong recommendation. If you are not currently implementing version control in your projects, I strongly encourage you to do so. We'll talk about how much it helps alleviate risk. But basically one of the things that Git gives you is a history of the changes that are made to your website. And I keep saying websites and code base out of habit. You can use Git on whatever files you want to. It does not have to be a Drupal site. It doesn't have to be a website at all. You could use Git on plain text files to keep track of changes. So how do we use Git? In general, there are different tools for using Git. My preference is to use the command line for committing. We'll talk about the terminology very soon. Committing is to save something to history. So if you want to save a change or a set of changes to history so that you can look back at them, you would do that in the command line. Merging and rebasing. Again, we'll talk about this soon. Tagging, creating branches, creating different versions of your repository. And essentially, almost everything that you do in Git, you do on the command line, except for collaborating. Now, what I mean by that is there are websites, github.com, Bitbucket, that allow you to collaborate when using Git. They allow you to create what's called a pull request. That essentially is a request of a team member to take your work and combine it into their work. Sharing code and commits. So for sending work that you've done to colleagues, and for accepting pull requests. So if somebody else asks you to pull their work, then you can use github.com to review it in a very easy to understand way, and to then pull in their work into your project. So I'm going to show you an example of that from a real project. Let me see. I'm just going to pull over a window. So here we have github.com. This is taken from a student project this semester. And we're looking at what's called a pull request. This is a student in the class. They are they created a pull request and they asked us to pull their work. So they said, I completed the following set of changes, what I have my rectangle around, and I would like you to take these changes and to combine them into our code base, into our project. This is the type of thing that's easier to do on github.com. Again, collaborating is essentially the all-encompassing word for the type of tasks that you perform on github.com. So when our teammate asks us to take their work and merge it into our site, I have a nice visual of what work they actually did. You can see a nice commit history. We'll come back to this. And the files changed. This pull request was not prepared specifically for this conference. This is a real pull request from a real project that's happening today. So here I can see what files were modified. So here's a file which is named Git Ignore. Here's a file, a Drupal configuration file in Drupal 8. And I can see what lines were added to these files. And it's a lot of changes. You know, it's there's a lot of new files. There are a lot of files that just have modifications to them. I'm scrolling very quickly. I was trying to find this. So here's an example of changing a word within a file. If I was collaborating with a teammate without Git, it would not be so easy for me to see exactly what they changed. You see here, not only do I know what file they changed, github.com actually not only highlights the line that changed, but it highlights the word that changed. That makes it really easy for me to tell what was changed in the site and and it lets me know, basically it makes it so that I won't miss anything. Nothing will slip under the radar. No one will make a change to a file and type something like testing debugging and accidentally merge it into our site. So none of that will happen. I get a very, very clear way to review everything by using github.com or a similar GUI for collaborating. Reminder that if there are questions, please ask them in chat. It's not disruptive to use the chat room, and I'll let you know if it's something we'll address later. Now, let's check. So these two slides are actually in the opposite order, so let me pull up the right slide first. So Git is decentralized. If you are familiar with other version control systems, one difference between some of them and Git is this aspect of it. Git is decentralized. It has a few implications, but what it really means is there is no central authority of the repository. Repository being the folder which Git is tracking. So let's say your website is stored in a folder called doc.root. And in the doc.root folder, you are using Git to track changes. The fact that it's decentralized means if I work on the website on my computer and I make a copy of the code base on my computer to work there, there is nothing saying that the copy on github.com or on the server is more official than the copy on my computer. Every copy of the repository of the folder being tracked by Git, every copy has all of the same features. They all have the same history. So Git itself does not enforce ownership of one repository over another, of one copy of the website over another. So that's, again, if you're coming from a different version control software, that often takes some wrapping your head around. So we do have some diagrams to demonstrate this. Let me just pull one of them up. One minute. So this is a diagram depicting a Git workflow. So every one of these folder icons, we have a bunch of gray folders, blue folders, and green folders. Every one of these folders represents a copy of the same project. So we have a copy of this project. It's just called proj.git. This is a Drupal website. In the bottom right, we have the production website. That's, the official website that's live. Now, we have a copy of the website on the staging environment. We have another copy on the dev environment. And we have copies on our developers' computers. We also have copies on github.com. So what I showed you a little while ago on github.com, that was one user asking someone to take work from their copy on github.com and merge it into the other user's copy on github.com. So we basically have a bunch of copies of the same repository, and the whole decentralized aspect of it says the prod copy is exactly the same in terms of features, in terms of authority, as the copy on my local computer. We'll talk a little bit about the implications of that. If I make a copy to any one of these, it only happens where I made the change. So if I make a copy in my local, if I make a change to the copy in my local, the change only happens there. It won't affect prod. If I make a change somewhere else, it only affects that place where the change was made. But with each of these repositories, we have a full copy of the history. This is important for a few reasons. It means that, one, if, let's say, something terrible happens and the production code base gets corrupt, you just lose it. I've seen this happen. I've seen this happen on a project where the site had not launched yet. We had a production behind the scenes. It was a 2 or 3 year project, and something went bad with the server, and we lost the entire code base. So, poof, production was gone. And it was irretrievable. We were not using Git. If we were using Git on that project, anyone on the team could have said, well, here's a full copy of the code base. Or on GitHub, they could have said, here's a full copy of the code base. Let's just push it back up to production and I'm sure there's some cleanup to do, but you'll at least have the full code base. It's a lot less disruptive. Because we were not using Git, we had to talk with everyone on the team and see who worked on what last, and we had to piece the project back together based on using the modules that each person had worked on. And that was a huge undertaking. So it helps you in terms of risk, but it also helps, I'll come back to that. It also helps because with you each having full copies of the site, you can each collaborate on your copies of the site. One of you can essentially say, I'm working on the following feature. And someone else can come and say, okay, well, I'm also working on something related. And they can create a pull request to your copy. They don't have to go through production. They don't have to say, wait until my feature is finished, I'll send it to production, and then you go get it from there. Instead, they say, let's work together. Let's merge our work together on your copy. We will not impact production, and so on. And as far as no central authority goes, you will still essentially have an official repository, but it will not be enforced by Git. It will be enforced by your team. So we could say something like, all right, we are all pushing to the Debug Academy GitHub repository. That one is the official one. This one over here, we could say. But that decision is a team decision. It's a convention you're agreeing on. It's not something that Git forces you to do. So the other thing that this diagram shows you is how people work on a project, most projects that are using Git. So you would typically work on your local machine. So I would work here. When my work is ready, I would send it to my GitHub account. So I have a copy on GitHub account of the code base. That's where I send my work. And from there, now that it's online, remember github.com is for collaborating. I'm done. I sent my work, and now I'm ready to collaborate. So from this point, I take my work from github.com and I create a pull request to the main repository. This is saying whoever's in charge of the canonical repository, look at the code changes I made, please merge them into your project. And I showed you an example of that a little while ago. That's what's happening right here. This is where Omar says, I completed the following work on my GitHub copy. Really, he completed it on his local. He pushed it to his GitHub account. And then he said, I would like you to take this from my GitHub account. So it says from Omar / this branch into Debug Academy's account. Debug Academy / develop. There's a lot of terminology. I've been throwing it around. Unfortunately, it is a lot, and it's hard to wrap your head around it without hearing it a few times and using it. But hopefully you'll understand what's being said, and if you don't, please say so in the chat room. A repository is a folder which uses Git, essentially. It's a folder which uses Git version control. It's easy to record changes in a repository. I will demonstrate some of these terms, the ones that are reasonably demonstrable, to also show you, kind of take away the intimidation that they might come with. So I'm going to create a folder in the command line. I'm creating a folder. I'll call it webinar. I'm going to open that folder. There it is. Okay, so I have a folder named webinar. It's open right here. Right now, it is not called a repository because Git is not tracking it. If I run git status, it will say not a Git repository. So it's saying this is not tracked by Git. To make it a repository, all that I need to do is run the command git space init, initialize. Initialize empty Git repository in this folder. The folder still looks exactly the same. It looks like an empty folder to me. The only difference is Git now put a hidden folder in there, one we cannot see. And in that hidden folder, it's going to store the history of changes in this folder, in the webinar folder. Now that we initialized an empty Git repository, meaning we ran git init, and it has this hidden Git folder which we can't see, this webinar folder can be referred to as a repository. So a repository is just a folder that Git keeps track of the history for. A commit is a change to a file or set of files that Git saves in history. Commits, they don't only store the changes, they also store who did the change, when the change happened, and a description of the change. So back to that example, pulling up. So here we see each of these is a commit. If I click the commits tab, I see that it says there are 7 commits. And in this, let's see, in this file, enabled the posse theme. Click that one. Actually, let me find one with less changes. So, still has a handful of changes. This shows what changed in the files, but what I wanted to really show was it says who changed, who made these code changes, and it says when they were made, and it shows a description. It was for task number 610, and the following change was made. So a year from now, if I want to see who made that change, there are multiple ways for me to do it using Git. I can see who made it, when they made it, exactly what lines were changed. So if you ever find a bug in your code base or code you don't understand and you want to talk to the person who wrote it, you can use Git to see who changed what when. And on github.com, you can actually see Drupal itself and all of the 34,000 commits in Drupal 8. So if you click on the 34,000 commits, you can see who did what change when. So is there something in Drupal that you are thinking, I wish I could speak to the author of this section of code so that I could find out, maybe I could call them and hire them to wrap something up? in Git, there are multiple ways for you to see exactly who made what change when. If this clones quickly, I will demonstrate something. I'm running the Git Clone command, which means I'm making a copy of a repository. So this is the Drupal repository from github.com. Remember, there's no official repository. This is a huge one. You saw 34,000 commits. It's downloading on my computer a copy of Drupal that has the history of every change ever made to Drupal. Let's see. Okay, so I'll come back to that. So that a commit is a change that saves in history. A branch is a version of a repository. This is one of the coolest things about Git. I realize that we're running short on time. I'll just hop into the Drupal folder. So I'm in the Drupal repository, and for some reason, let's say I wanted to know who wrote the readme.txt file. And I want to know who wrote the first few lines of it. Git has commands for telling me that. This one's called git blame. Angie, if you're in tune with the Drupal community, there's a good chance you've heard of her. She wrote the first few lines of the readme.txt. So you could do this for any module on Drupal.org, and you can say, who added this line? See, Angie added these lines. Jennifer Hodge, I'm going to pronounce it wrong, she added this line, and so on. And you can get more information. It says what commit they did it in. I can look at that commit. You can see the description, issue number so-and-so, by the following people, fix up, encourage, good placement of themes, modules, and profiles. And you can see the changes that were made. All this text was written. So that's just an example of one of the powerful things you get with Git, a full, deep history of changes. A tag is a snapshot of your repository at a certain point in time. A tag doesn't change. You take a snapshot, it stays a snapshot. So when you do a release to production, it's typical to take a tag at that time. To check out is to switch between versions of the repository. I am moving a little quickly with lines like these. I hope that you can look back at the recording of the presentation and maybe pause it on these slides. This is typically a longer presentation in my 3-month course. We actually teach Git over 2 classes because there are many more commands in Git for you to get the most out of it. A fork is a copy of a repository. Typically, it diverges from the original. To merge is to combine work from different sources, like when Omar is asking me to merge his work into my repository. Merge is the right word. If I decide to combine his work into mine, I would say git merge, the name of the branch. You can see a visual of the commits. A commit is a snapshot at a point in history. Commit A, maybe when the project was initialized. B, maybe you created the README file. C, created index.php, and so on. We talked a bit about commits. Commits should be granular and they should show your thought process. One thing I like to do is I like to use my commits to tell the customer what I did. So if I have a project, I have one in particular. Excuse me. All right, so if I look at the log for this project, the history, I can see what work was done. Added the session limit module, generate invoices only on invoice save, support multiple names, etc. If duplicate is created, existing one is used. And these are all relatively small changes. These are the type of things that developers often forget to include in their timesheet. Small changes. So if your client ever comes back to you and says, you billed me for 8 hours, what did you do all that time? I will sometimes print out the Git log and show them exactly what I did. And I've never had an unhappy customer looking at a Git log. You do good Git messages, good Git commit messages, and you do them early and often, it becomes a real proper record of the work that you've completed. Branches, they allow you to work on different tasks in parallel. So someone might be working on the main development work, and then a bug comes up. At that time, you can create another branch and work on that bug, on fixing that bug in parallel, while maybe the rest of your team continues on the master branch, or while maybe you need to jump back and forth for one reason or another. Your work will stay separate even though it's in the same folder on your computer. Git will handle hiding it when you're working on a different branch. Merging branches just involves running the git merge command, and that will take two branches and combine them together. In the diagram with all of the different remote copies, you can add remote contacts to your Git folder to say, I want to be able to send work to Debug Academy's GitHub account, or I want to be able to pull work from it, or I want to be able to send work to my colleague's account. That's just like adding a phone number in a phone book. Instead of putting a name and a phone number, you're putting a name and a URL to their repository. Just like a phone number in a phone book, the phone number is important, it can't change, but with the name, you can put whatever you want, technically. It's just, could be thought of as a nickname. Talked about pulls a few times. You pull work to download it and into your current branch. You can pull it from some other repository. Pushing is the opposite. You push work to send it. I know I went through those two slides very quickly. There's just one visual aid for Git that I think is really helpful. I'm going to do it really quickly. I'm creating a file named master.txt. And I'm going to git add the file, which means I'm saying this file will be saved to the history the next time I do a commit. And now I'm doing a commit. Created master file. That's the message I'm going with for my commit. So this file, master.txt, is now saved to my current branch, my current version of the repository. If you look at the folder, you'll see it right there. I'm going to open it in Sublime Text. It's just a text file that says this is master.txt. So what I'm going to do now is create a new branch. Just going to call it other branch. On this other branch, I'm going to create another file. Other file.txt. I'm going to add and commit it. On the right here, you see I have both files now. I have other file and I have master. Everything makes sense so far. I just committed other file to the other branch, which is a version of the repository. I'm going to switch back using the checkout command. I'm going to switch to the master branch. So I'm leaving my other branch. I'm going back to my master. So remember, that's two versions of the same repository. And when I do that, I want you to keep your eye on two things. I want you to keep your eye on the window on the right where it says master.txt and other file.txt. So in 3 seconds, I'm going to switch branches, and I want you to watch that folder that currently has master.txt and other file.txt inside of it. So in 3, 2, 1, I switched branches. Notice other file.txt disappeared. It's gone, and that's because I switched to the other version of my repository, the master version, which doesn't have other file committed to it. I didn't commit other file to my master branch. I only committed other file to my other branch. So when I switch back to my master, Git says, I'm going to a different version of the folder. The other version should not have this file. And it takes the file and it hides it in Git's hidden folder. If I switch back to the branch, Git checkout other branch, you can see it reappeared. The file just came back. All right, I see there's 5 minutes left. That's the main visual representation of this. I'd like to give people a chance to ask questions, if that's appropriate. This is my first Drupal for Gov webinar.
Yeah, no, absolutely it is. I mean, I think I don't see anything in the chat, but folks, so if you've got anything, go ahead and in the chat. Seems to be a relatively quiet group. If you want to go ahead and unmute yourself and ask the question, I say we go for it. So. Feel free to either unmute yourself and ask, or go ahead and post your question in the chat.
There are no stupid questions. There's different levels and different levels of experience with the same topics. I'll pull up this other slide for the background. But if you want to ask about how to use Git on your project, it is possible to start using Git on an existing project. Can you get a copy of the slides? Yes, you can. I'll be emailing the webinar attendees with a copy of the slides. And it looks like Drupal for Gov will be posting the recording and a link to the slides. Thank you for asking. And like I was saying, you can start using Git on a project. One more use case or advantage of using Git is, there's one question. So I'll say the advantage of using Git real quickly. One of them is that, and I'll set up to answer your question while I'm answering it. So one of the advantages of using Git is if your server were hacked and someone were to modify files on your server, you could, let me do this on my monitor, you could so if someone were to hack your server and modify files on your server, with a simple git status, you can see what files were changed. And because you all have copies of the history, it's not possible for someone to make a change to production without you noticing when you merge your work from local to production. So it really gives you a big boost in security. If you were around for Drupal Get-In when there was a hack that or a patch that the security team released that was very important, if you did not patch your site, having Git really helped out a lot because you could see if any of your files were modified. So to the questions in chat, the shorter question is, how does this affect the Drupal database if there are changes made? It does not affect the database at all. If you are managing your configuration in code and you export it to the code base, then it will affect that because it'll be part of the code. Git does not see your database at all. The other question was about managing merge conflicts, and I will show that in just one moment. So if you have, what a merge conflict is basically if you have made changes to the same file. So I'm on my master branch. I'll make a file, index.html, some changes here. I'll add and commit that file, so I'm saving it to the history. I'm creating a new branch, and I'm doing this very quickly. And I'm going to make some changes. All right, so I'm modified line 1. And if I go back to my master branch and modify the same line, and modified line 1. So what I'm setting up for right now, I'm not expecting you to follow what I'm typing if you haven't used Git before. But what I'm setting up for is I made a change to line 1 on 2 different branches. If I tell Git to combine those 2 branches, Git won't know which one I want to keep. It won't know what to do with the changes. You can think of it like if you're writing an essay with a classmate and you both modify line 1 of the essay and you want to combine your essay. You can't say mine goes first and yours goes second until you've read both of the lines. So I'm going to run git merge master 2. And it says there's a conflict as expected. Merge conflict in index.html. You do not necessarily. So the next problem is not really a Git problem. You now open the file in whatever your favorite text editor is. Let me bring that over here. This one in the middle. Where it says head, that means the most recent commit on the current branch. Where it says master 2, that's the branch that I'm merging in. It's saying one branch said this, the other branch said this. And Git is saying, I don't know which one you want to keep. I don't know what you want to do. So Git is just telling us these 2 lines, these 2 changes were made on the same line, and you asked me to combine them, but I don't know what they say. So you fix it yourself. So when you have a merge conflict like this, you delete anything you don't want. I don't want a bunch of equal signs or greater than signs. And you make it say what you want to say. So you can rewrite the sentence. It's not a Git problem at this point. It's a content problem. So I rewrote the sentence. I'm happy with it now. And then I would git add the file and git commit the file, fixed merge conflict. And that's how you resolve a merge conflict. Let's see. Does Git show even new nodes created or edited nodes on prod? No, it doesn't, because nodes are stored in the database. Content is stored in the database, and Git doesn't see the database. So this is used for things like code changes, really. You could think of it as code change, a tracker for code changes. How do you move the changes from test to production? And how do you have two independent sets of changes in test and only deploy one to production? So all of your branches have names. If I run git branch, I have a master 2, and you'll name your branches based on the tasks that you're working on. So branches and tags. Remember, branches are different versions of the repository. Tags are snapshots of the repository at a specific time. So you would take the branch that you want, and you could think of it as you would CD to production, and you would check out that branch, or you would pull that branch. So whichever branch it is that you want production to have, you're essentially checking that branch out or pulling that branch to production. If you're using something like Acquia or Pantheon, under production, you're going to have a dropdown that says what branch is currently there, like master, and or what tag is currently there. And you can click the dropdown and you can pick a different branch. So it will take whichever branch you want, whichever branch you pick, and it'll apply that code to production. So if you're using Acquia or Pantheon, you usually do it through a dropdown. Otherwise, you might go to production and check out the branch that you want on production, or pull the branch you want to production. Another question is, should .ds_store files always be ignored to avoid conflicts? There are many hidden files that don't benefit your website that should be ignored. So ds_store is a good example of them. If you use SAS, you might see a SAS-cache directory, and that's a cache directory that stores essentially short-term memory for SAS. You could think of it like that. This is something that you would want Git to ignore. .ds_store is another thing you would want Git to ignore. Sometimes you want Git to ignore log files, anything .log. And there's, if you use PHP Storm, it may generate files, and there's a good chance you want to ignore those too. If we look at the Drupal that we cloned, find it, you can look at what they ignored. There's a hidden, actually see. I'm not finding it there, but we do have it here in our class project for this semester. There's a hidden file named .gitignore, and that file contains a list of files that Git should ignore. You can see what Drupal recommends ignoring, and it's a lot. Your settings file, they recommend not saving this to your history because it contains passwords. Files generated by PHP Storm. And you could see my current semester, we're building a project in Drupal, and we added these. We're ignoring ds_store, SAS cache, and CSS map files. So yeah, you would ignore anything that doesn't contribute to the website and would regularly cause conflicts and things like that. People usually ignore their file directory because they don't want user uploaded files to be stored in their commit history either, because it would just make the repository very bulky and have too many files. Thank you for the questions. Are there any more questions?
So it doesn't look like we have any more in the chat, and we're almost 10 minutes over, so I'm going to go ahead and call it at this point. Thank you, Ashraf, for the seminar. I know this is a lot of information and a hard topic to do in an hour. So thanks to those of you that stuck in for this one. As I mentioned earlier, this webinar will be recorded and we will be sharing the slides. So if you don't already follow @govdrupal. On Twitter, please do so. That's been our primary means to kind of shoot out where all this stuff can be found. But you can also reach us at drupal4gov@gmail.com as well if you have any questions about anything. But otherwise, thanks, Ashraf, and thank you, everyone, for participating. And we hope to see you at our next webinar series, which will be held on the third Thursday of April, the 19th at 3 p.m. Eastern Standard Time, where we will be talking about using analytics data to drive some of your content-based decisions. Thanks, everybody.